Welcome, chemistry students, to another flipped lesson. Today our focus is going to be on understanding evidence for a chemical reaction and chemical equations. So our objectives for this lecture are to learn the signals that show a chemical reaction has occurred, which are very, very similar to the signs of chemical change we learned in the last chapter, and also to learn to identify the characteristics of a chemical reaction and the information given by a chemical equation. Because from this point forward, we're really going to focus on what's happening to the atoms in compounds when they do chemically react with each other. And we do that through writing chemical equations. So let's go ahead and get started. Make sure you've got your notes out and probably a periodic table as well. So clues a chemical reaction has occurred are very, very similar to the signs of chemical change. So in the last chapter, we learned that if we have a color change, it could mean something chemical is happening. That's going to be the same thing to understand that a chemical reaction is occurring. Now remember, these color changes need to be significant. So if I put red food coloring into water and it turns red, that's not an unexpected color change. That's not a sign of a chemical change. However, if I put something red into a solution and it turns pink, or purple, or blue, or yellow, that is a significant unexpected color change. So your color change needs to be definitely unexpected and dramatic. So that would be a sign a chemical reaction has occurred. Another sign is a solid forming. And remember, this has a special name in chemistry. We call it a precipitate. Excuse me. So you definitely want to add that word to your notes so you can remember that solid and precipitate in chemistry mean the same thing. Bubbles producing, remember from the last chapter, means we're making a gas. So very often if you see bubbles or if you hear fizzing or if you see like a foamy substance, that could definitely mean a chemical reaction is occurring. Anytime you see a flame occurring, no matter what, it's going to be a chemical reaction because that means combustion is happening and so you're burning something. And anytime something is burnt, it definitely means that you're chemically changing it. So this one's a new one, that flame occurring. If heat's given off, what's going to happen is your test tube is going to feel hot, just like in that chemical change lab that we did, where you guys put the magnesium into the acid and the test tube felt very, very warm to the touch. That's definitely a sign of a chemical change. Anytime you start with something at room temperature and it just all of a sudden gets really hot when you combine it with something else, definitely clue that a chemical reaction is happening. And on the other side, if heat's absorbed, your test tube is going to feel cool. So if you start with something at room temperature and you mix it with something else and all of a sudden it feels very cool, that could definitely be a sign a chemical reaction is occurring. Now remember, when we're looking for chemical reactions, we often want to see at least two of these things occurring at the same time because that's really a big indicator that it is a chemical reaction. Sometimes one of these things just isn't enough to really solidify that it is chemical. So we typically see at least two of these things happening together. So let's go ahead and talk about chemical equations. When we look at chemical change, what's always happening is we're rearranging atoms to form new substances. So this is super, super important that you make sure you get that word down in your notes because we're creating something new by rearranging the atoms that we're putting in. So if we look at the example in your notes, CH4 gas is called methane. So methane gas will burn with O2 in the air to form CO2 and H2O. This process is called a chemical reaction. And if we look, the substances that we're putting in, our CH4 and RO2, are very different from the substances that we're getting out, which is our CO2 and our H2O. So that's a sign that you know you're having a chemical reaction occurring when the stuff you put in is different from the stuff that you get out. So let's go ahead and let's write an example chemical equation for this. What we're going to do is we're going to start with the stuff that's put in on the left side of your paper. So we're going to write the two substances we see, which is CH4 and O2. In math, you kind of separate equations with equal signs. In chemistry, we separate them with arrows. So these things that you start with have a very, very special name. They're called the reactants. And the reactants are what you put into a chemical equation. So the reactants are what are going in to react. So if we look at our sentence, we've got two compounds that are being produced by these two things reacting. So they would go on the right side of the arrow. So we would copy them down as CO2 and H2O. These things are called your products. And this is what you get out of a chemical reaction. So these things are made, by a chemical reaction. So when you're writing a chemical equation, it always starts with your reactants and it always ends with your products. And what we do with this arrow is you either read it as yield or to produce. So if we were reading this as a chemist, we would read it as CH4 plus H2O, or sorry, CH4 plus O2 yields CO2 and H2O, or CH4 plus O2 react to produce CO2 and H2O. So this arrow is kind of showing us the change that's happening. So we're starting with these reactants and they're changing into these products. Now some other information that we get from chemical equations are the state of matter. And the really important thing to think about when we're doing chemical reactions is atoms are not created or destroyed. So if we go back to the last slide and we look at it, in my reaction I have C's, H's, and O on the reactant side. I have C's, H's, and O's on the product side. So we're not creating any new atoms and we're not destroying any of the atoms that we started with. And that's a really, really, really important thing that you need to remember all year, is that we're not creating or destroying atoms in chemical reactions. We're simply just rearranging them into different compounds. So when you're looking at a chemical reaction, you must have the same number and type of atoms on both sides of the reaction. Now I know in the example that we just did, our number of atoms is not the same. We have more O's on one side and more H's on one side, and that's fine, because what we do to make them the same is something called balancing, and that's going to be something we'll focus on later in the week to understand a little bit better. But the key thing to think about when you're writing a chemical equation is the atoms that you put in have to end up on the product side, because we can't make any new atoms, we can't destroy any of the atoms that we have. So that's a really, really important concept in chemistry. Now, chemical equations not only tell us what compounds are involved, so what we're putting in and what we're making, but they also tell us the physical states of matter of each compound, which is very, very important for classifying chemical reactions, which is something we'll do in Chapter 8. So what we need to be able to do is understand the symbol that we see and the state of matter that it represents. So if you see a lowercase s in parentheses next to a compound, it means that the state of matter is a solid. If you see a lowercase l, that's a lowercase l, that's the best I could find. You know, I kind of like to do like the little cursive L so it doesn't look like a capital I. So if you see a lowercase l next to a substance, it means it's a liquid. If you see a lowercase g next to a substance, it means it's a gas. And if you see the symbol AQ next to a substance, what this means is it's something that we call aqueous, which means it's dissolved in water. So this would actually be anytime you see the word solution. So a lot of the things that we've been calling liquids up till this point truly aren't liquids. What they are is they're solutions of compounds that we've dissolved in water. So it's very important to note that we really don't work with a lot of liquids in chemistry. I mean, water is a liquid and there's a couple other liquid elements. The majority of what we work with in chemistry that looks like a liquid is actually this guy here, aqueous. So it's actually stuff that's been dissolved in water. So for example, I'm going to go ahead and erase that. Oops, wrong thing. So for example, if we look at this example equation that we have, which I believe you all have on your notes, we have this equation here. So K solid plus water liquid yields hydrogen gas and potassium hydroxide that's aqueous. So we can see the different states of matter next to the different components of that chemical reaction, identifying what state each thing is in. So let's go ahead and try and writing some equations from words. So if we look at this first example in your note packet, solid mercury 2 oxide decomposes to produce liquid mercury metal and gaseous oxygen. So the first thing we want to do is we want to identify where the reactants are and where the products are in this word equation. So as we read, we hit this word decomposes. What that word tells us is this is where the chemical change is occurring. So anything before this is going to be a reactant and anything after it is going to be a product. So I like to underline my compounds and identify them as either a reactant or a product. So this mercury 2 oxide comes before the decompose, so this is going to be a reactant. Liquid mercury metal comes after the word decompose, so it's going to be a product. And gaseous oxygen comes after the word decompose, so it's going to be my other product. So we can go ahead and we can write the chemical reaction for this equation. So if we look at the compound up here, if we remember from naming, this Roman numeral tells me that the mercury is a +2 ion. If we look at the periodic table, we know oxide comes from oxygen, which is a -2 ion. +2 and -2 are the same charge, so my compound is simply going to be HGO. It tells me it's solid, so I'm going to put a subscript S next to it. That's the only reactant I have, so I draw my arrow, because that's going to make liquid mercury, so that's going to be Hg with a little L next to it, and gaseous oxygen, so O2 with a little G next to it. And that's it, that's all we have to write, because at this point we don't need them to be balanced. We're going to learn that later. Right now we just want to focus on writing proper chemical equations. So let's go ahead and let's try a second one. Solid carbon reacts with gaseous oxygen to form gaseous carbon dioxide. So if we read this one, when we hit this word to form, that tells me this is where my reaction is stopping and I'm making products at that point. So solid carbon is going to be my first reactant, and it's telling me it's reacting with gaseous oxygen, which is going to be my second reactant. Gaseous carbon dioxide is the only thing I'm going to have as a product, so now we can go ahead and we can write our chemical equation. So solid carbon would be a large C for carbon and a subscript S next to it for the state of matter. We put a plus sign to separate it from the gaseous oxygen. Now this is where those Hankel-Briffs come into play. Remember, gaseous oxygen just isn't O, it's O2 because it's diatomic. So do not forget your Hankel-Briff. All those atoms, when you see them by themselves, are going to be diatomic, so don't forget that. We put a G next to it, and then it's going to form, so we use an arrow, gaseous carbon dioxide, which would be CO2 with a lowercase g. What I'd like you guys to do is try and do this last example on your note packet, okay? I want you to do your best to come up with the chemical reaction, and we're going to go ahead and start with this in class tomorrow. I'd also like you guys to head over to the Google form once you're done with this and answer the questions. Remember, if you have any questions, you can either email me or come in early for help. Have a great night, guys.